Major League Baseball.
Hello and welcome to Algebra. Today we're going to learn about how to find the domain and the range of a graph. Okay, so let's do a quick reminder. All right, so domain is our x values, okay? And when we look at a graph, we want to put our domain from least to greatest. So when we look for domain, we want to look from left to right, okay? The range is a set of our y values. And when we're doing range, we want to go from least to greatest. So that means on a graph, we're going to go from down to up, or start from the bottom and work our way up. Okay? All right, so that is how we're going to find the domain and range of these graphs. All right, let's get started. All right, so this says list all values of the domain. Okay, so I can see this line stops here because there's a point, and that point is on -1. So -1 would be a value. If I'm keep going, I can see a point here that's at 0 on my x, right? I see a point here that's at 1 on my x. I see a point here that's at 2 on my x. I see a point here that's at 3 on my x. I see a point here, which is 4 on my x. And I see a point here where the line ends with this dot right here, and that's at 5. So my domain has all these numbers, -1, 0, 1, 2, 3, 4, 5. All right, and we plotted those points already. So let's list some values that would not be in the domain. So some numbers that could not be in the domain. All right, so like 6 would not be in the domain because the line stops here. It wasn't an arrow, it was a dot. So that means it stops there, so it's not going to keep going on. So 6 is not in the domain. 7, 8, 9, 10, anything bigger than 5 would not be in the domain, right? Well, let's look on the other end. It stops here, so like -2 would not be on my graph, right? So like -2 wouldn't be on there. -3, right? Anything smaller than -1 would not be on my graph because it stops right here. So how could I write that in an inequality? Well, if I see here, all my x values are between -1 and 5, right? So that means x has to be bigger than or equal to -1, but smaller than or equal to 5. So that would be C here, because x is bigger than that -1 or equal to, and it's less than or equal to that 5. All right, let's do it for the range. Same thing. If I'm doing range, I'm going from bottom to top, right? So bottom to top, I see a point here, that is at 1. I see a point here, that's at 2. I see a point here, which is 3. I see a point here, which is 4. I see a point here, which is 5. I see a point here, which is 6. I see a point here, which is 7. So I see all those points, right? What are some ones that would not work? Well, this one stops here at 1. It wasn't an arrow, it was a dot. So it's going to, that line stops here. So 0 would not be an answer. -1 would not be an answer, right? Let's look at the top end of our thing. It stops here, so that means that 7's our last thing. So 8 would not be an answer. 9 would not be an answer, right? Anything bigger than 7. So all of my range is between 1 and 7. So that means my y has to be greater than or equal to 1, but it's less than or equal to 7. And the way I show that in an inequality would be like B right here. The y is in between 1 and 7. It's bigger than the 1 because the opening is towards the y, but smaller than that 7. All right, and that's the range of this graph. All right, list some values of the domain. All right, so list some values of the domain. I see there's an arrow here, so that means that's going to keep going on forever and ever and ever. All right, so what are some possible values? And I see this ends here at the point, so that ends at 4. So it can literally be anything that's less than 4, because it stops here and it's going on forever that way. So it could be -1, which would be here, it could be 0, which would be here, it could be 4, which is right there. Can we list all the values of our domain? No, we cannot, because this is an arrow. It's going to keep going on forever and ever and ever towards our left, right? But it stops here. So what are some things that could not be in our domain? Well, 5 can't be there, 6 can't be there, 7 can't be there, because it ends right here at 4. It's not going anymore to our right. Right? So the arrow means that it's going to keep going on. The point means that it stops there. So it can't go anymore. So what is my domain? How would I write that as an inequality? Well, I could write that as an inequality because I see it stops at 4 and it keeps going on to the left. So that means 4 is the biggest it can be, but it can be any number smaller than 4. So it would be x is less than or equal to 4, which would be E here. Okay? All right, let's do the same graph, but do the range. All right, this is the same graph. Here's an arrow, so that means this line's going to keep going up. It's going to keep going up. All right, so what are some values of the range? Well, it can be any number that's bigger than this dot. This dot tells me it ends, and that dot is at -4. So it could be -4, it could be -2, it could be 0, it could be 1, right? It could be 5, right? So let's plot some of those. -4, -2 would be right here. 0 would be right here. Oh, sorry, not 0 would not be right there. 0 would be here, sorry. It could be 1, which would be here. It could be 5, which would be like way up here off the graph somewhere. Okay? What are some values that would not be in our range? Well, if it stops here at -4, that means it can't be anything that's less than -4. So like it can't be -5 because this graph stops. It's not going on this way, right? So it can't be -5, it can't be -6, it can't be -7. So how do I say that as an inequality? Well, y is greater than or equal to -4 because it stops here at -4 and it's going up and it's going to keep going up. It can be any number that's bigger than -4. So it's y is greater than or equal to -4. All right, let's look at this graph. All right, so I have this graph. It has 2 arrows on it. It's got an arrow going. That means this is going to keep going that way and expanding, and this is going to keep going that way and expanding. Okay, so let's see. Let's sum values of our domain. Well, our domain, it could literally be any number on this axis here, because -5 is on the line, -4 is on the line, -3 is on the line, -2 is on the line, -1 is on the line, 0 is on the line. Even if I went over here to 10, because this is an arrow, it's going to keep going. Like 10 would be over here somewhere. I can go up and it would still be on the line, right? So it could be anything. So these 2 arrows tell me that it's going to keep going on forever and ever and ever, right? And that means that it can literally be any number. It can be all real numbers. It can be all real numbers. Any x value I can think of, it would have a point on the line. All right? So let's think about that as the same graph as for the range. All right? For the range, it says list some possible values. So remember, ranges are y, so we're looking up and down, right? So I see that it starts, the bottom of my graph is here at -4. So like -4 would be a point, right? And anything, since these are going up, these are going to keep expanding, right? It could be -2, it could be, or sorry, -3, -2, -1, 0, 1. All these will have points on the line, right? All these have points on the line. So it can be any of those numbers. It could be -4, -3, it could be 4, it could be 10. Because 10 would be up here and it would still be on the line, right? So how could I write that? How could I put that on my thing, right? So the bottom is, the smallest it can be is -4, because that's the bottom of this curve and then goes back up again. But it can be any number that's bigger than -4, so it would be y is greater than or equal to -4. All right, let's try a couple others. All right, this one's very similar. I got 2 arrows. That means this is going to keep expanding that way. This is going to keep expanding that way, right? So list some domain values. Well, domain values are my x, and I see on my x, no matter where I put on x, every x value is going to have a point somewhere on that line, right? So it can literally be anything. It could be -5, it could be 4, it could be 10. It doesn't matter. Any number I put in is going to work. It's going to be, we can find a point on that line. So once again, this one is going to be all real numbers, because any positive or negative number I can think of will have an x value on this line. All right, what are some values of the range? So range is up and down. I see the bottom of my thing starts right here at 2, and it goes up, and it's going to keep expanding that way. So some possible values would be like 2, 3, 5, right? 10, any of those, right? So 2 is right here on the graph. 3 would have 2 points. It'd be like here and here. 5 would be like up here and here, right? 10 would be up here somewhere and be like here and here. Okay, so any number that's bigger than 2 would have a number, or would be on this graph's line. So this would be, that means that y is greater than or equal to 2. It can't be smaller than 2 because the graph stops here. It can't be like -3, for example. There's nothing on -3 because the graph is going up. So it has to be any number that's bigger than or equal to 2. All right, that is how we find domain and range of a graph. All right, if you ever get a graph and it's just points, and it's just plotted points, all you do is just list the points if you have them. These are continuous lines, So we use inequalities because y is greater than 2. It can literally be any number that's bigger than 2. Right? So that's how we do it. We have to figure out where is our minimum maximum points for our domain and our range. And we've got to remember that the closed circles means that that line stops right there, and that arrow means that it keeps going on forever and ever and ever and ever and ever. Okay? All right, so that is how we find the domain and range of a graph. If you ever have any questions, please ask your teacher, and I'll catch you next time. See you later.